All right, guys. So this will be the last lesson for this week. um, this will also be the last lesson for our unit here. Next week we will start getting ready for our test, and so we'll kind of get ready here and jump in. So our last lesson is going to be over graphing radical functions. So you want to make sure you have your calculator today. So make sure that it is nearby for this lesson today. So let's take a look here at some essential understanding. A square root function is the inverse of a quadratic function that has a restricted domain. A horizontal line can intersect the graph of f of x equals x squared in 2 points, where f of negative 2 equals f of 2. For example, thus a vertical line can intersect the graph of f of negative 1 in 2 points. So that means that the inverse function is not a function because this fails the vertical line test. So again, that's how we determine if a graph is a function. If I can draw a vertical line that has 2 points through that vertical line, then that tells me that that function is not, or that graph is not a function. Okay. Now, there are cases, however, that you can restrict the domain of f so that the inverse of the restricted function is a function. So again, if we draw that same graph and then restrict it, that original function to where x is greater than 0, again, when you do the inverse of that function, you just replace x with y, and now you're drawing that same graph to where y is going to be greater than or equal to 0. It's that same domain that was restricted in the original one, except instead of x, now it's using y. Okay, so some families of radical functions here. Inverses of the power functions y equals x to the nth with domains restricted as needed form parent functions. For families of radical functions in particular, f of x equals the square root of x is the parent for the family of square root functions. Members of this family have the general form of f of x equals a square root of x minus h plus k. So also understand just the families of our radical functions. If you have a parent function, it can be written in radical form also. Just know this is a good reference for you to refer back to on many different things there. So again, we have a reflection. If it's a reflection across the x-axis, it has a negative in front of it. It can either stretch or it can shrink depending on what the a is in front of that square root. And then the translation part of it, it'll move left and right horizontally by h, which is on the inside of that square root, and k, if it's on the outside, moves it up or down, depending on what that number is. Okay. Again, this is a good reference for you if you need references to go back to during this video. Okay. Example 1 here. Translating a square root function vertically. All right. So this is what I tried to prepare you guys with. Make sure you have your calculators here. All right. So your first step when you're looking at these graphs is you want to start with the parent function. So on this one here, all we want to do is just graph first y equals the square root of x. So graph that one first in your calculator. Go to your y equals, type in y equal, or as Charles said, just type in the square root of x. Then you type in square root of x minus 2, and then type in the square root of x plus 1. All right. Then from there, we're going to look at these two graphs and see how these are changing. Right? We kind of talked about this in our families there from the beginning there. So if you graphed all three, it should look something similar to this. That dotted line that we see there is our original function of y equals x. That's our parent function. Okay. When we saw the x minus 2, we saw that it is the same graph. It just moved down 2. And the square root of x plus 1 moved it up 1, but it was the same exact graph. So again, if we see a number on the outside of our square root, plus 1, minus 2, whatever number it may be, just know those are moving vertically. Plus move up, minus moves down. Okay, so again, that's how we will move vertically. All right, translating a square root function horizontally. So again, with these, start with your parent function. So again, go back in your y equals, type in y equals the square root of x. And on these, make sure you're careful. Now your plus and minuses should be on the square root. So previously, if we go back to that first example that we saw, these were on the outside of our square roots there. So this is the difference. Those are on the outside. In example 2, these are on the inside. Okay. So again, on the inside there, then you'll type in on that second and third function, square root of x plus 4, and then on the next third one, square root of x minus 1. See how those graphs have translated. So again, after you have graphed, you should be able to tell from the parent function, which starts at 0, the inside ones are going to move a little bit differently. Plus is going to move to the left. So we see that x square root of x plus 4 starts at -4 there, and the square root of x minus 1 starts at +1. So it's always going to be set equal to 0, and they solve for x there. So that's why those are a little bit different than our vertical ones. So just be careful about the inside ones. Those are always opposite. Okay. So example 3, graphing a square root function here. So now we're putting it all together here, right? We know that the outside number is smaller, right? That this graph is going to shrink. All right, so we know it's going to shrink because our a is less than 1. If a is bigger than 1, so 2, 3, 5, whatever it may be, it's going to stretch. Stretch or shrink, those are the two terms we're going to be using here, okay? Now, if we see the negative, then that means that we are focusing here on our graph flipping across the x-axis here, right? So again, all we have to focus on here is with our square roots, we want our x to be bigger than or equal to 0, right? So again, that means that our x here is going to end up starting at 3. Because again, if I were to plug in 3 for x, 3 minus 3 is 0. That's the lowest it can be. I cannot have a negative on the inside of that square root there. So from 3, right, we need to find x's that are going to end up giving us a positive, or that are going to be on the opposite side of our x here. So normally if that negative wasn't there, it would go up like normal. But with that negative, our graph will be focusing on the part that goes down. That's what that negative is telling us here. Okay, so as we can tell here was our first step, graphing the entire function there. So if that was a positive 1/2, then we would have focused on that bigger part right there, which would have been the top part that was going up. But with that going negative, now we're going to go to the bottom part there. That's the part that we're going to focus on. Okay. Now, that was our parent function. So with that negative 1/2, that's why I told you we were going to focus on the bottom part. And then we incorporate everything else there, where we move to the right 3 and we move up 1, and we end up shrinking that graph there. So again, all we typically have to do is type in that equation into our calculator, and again, find the vertex for where it begins, and it kind of repeats itself there. But again, that's the point that's going to be our vertex, and we're focusing on the part that goes down with that negative being there. Okay. All right. Example 4, solving a radical equation here. So this is the one where you need your calculator for this one here. Okay. So multiple choice. You can model the population of P of Corpus Christi, Texas between the years of 1970 and 2005 by the radical function P of x equals 75,000, the cube root of x minus 1950, where x is the year. Using this model, in what year was the population of Corpus Christi? So you will need your calculator for this. So the way you're going to type this into your calculator, before you do anything else, let's clear our RAM here. Let's make sure we start with something new. Second plus 712. Start with a fresh calculator so that we're all on the same page here. Okay, as you can tell, my RAM's been cleared. Hopefully you're doing the same thing here. Okay, so I go to y equals here, and I'm going to type in, you can type in the same thing with me here. So I'm going to do 75,000. Then we're going to do parentheses x, x minus 1950. And instead of doing the cube root there, I'm going to do that in parentheses and then raise it to the 1/3 power. Again, it's the same thing. Okay, so I'm going to raise that parentheses to the 1/3 power. Right? And then I'm also going to end up doing since we're trying to find what the population was for 250,000, I'm going to do 250,000 on a separate graph here. Okay. So again, as you can tell, I have two equations going on there. Just kind of showing you. All right. So I'm going to go ahead, hit graph here, and it's going to look a little bit strange here. So I'm going to kind of show you here. It's going to look, you may not even see anything. Okay. And that's fine. So what's going to happen here? Once this finishes loading here, it may take a while. I'm going to hit zoom, and then I'm going to scroll down to where I see zoom fit. It should be, I think, number 0 there. I have it highlighted, but zoom fit. And I'm going to press enter. Okay. So now here's the tough part with this one also. Okay. Whenever you graph it here, it's going to come up a little bit weird. And again, I'll show you how to fix it once it finishes graphing here. But I'm going to show you what happens. Okay. So when it finishes, it's going to look like this, where you see those two lines. And again, it doesn't get to where we need it to. So this is how we're going to change it. Okay. Now we're going to hit window, which is right next to y equals. So I'm going to hit window. Okay. And we're going to change that x-min and that x-min and x-max there. Okay. So for x-min, I'm going to put negative 3,000. So negative 3,000. And x-max, we're going to put 3,000. So as you can tell, negative 3,000 for min, positive 3,000 for max. All right. Now I'm going to go back to my graph here. And it should... All right. So it should give me a little bit better of a graph here. So what I'm going to do here is I'm going to hit trace. Or actually, I'll take that back. I'm going to do second, and trace. Second, trace. And a menu pops up. I'm going to go down to number 5 where it says intersect. The point where these parts intersect should give me the year of when this happens here. So I'm going to hit intersect. Okay. Now your first part that you have to do, it says first curve. It doesn't matter which curve you pick, but we're going to end up picking both lines here. So I'm going to hit X, or I'm going to press enter. I'm going to press, and when you press enter, then it should go back to the other line. I'm going to press enter, and then it's going to say guess. When it says guess, you have to go find where those two lines intersect. All right. So again, I'm just arrowing over here until I see about where they intersect at. Okay. Once you find close to where their intersection is at, press enter. And then if you look at what the X is, that should be the year that you're looking for there. So when I look at the X, it says 1987, which if I look at my answers there, that is answer C. So again, it's the intersect button. All right. And then you go between your graphs, and then you just trace to where the intersection is. Okay. So that's a tool that you could use for problems like these. All right. Again, a lot of calculator-based stuff here, so make sure you have your calculator with you for these. All right. Example 5, graphing a cube root function. So same type of problems here. So what's the graph of this? Type it in here. Understand what this is also saying here. So again, with our cube roots here, how is it translating here? So again, if I start with my parent function there, I can already tell how this is going to be translating. So if I take a look, it should be translating to the left one because, again, the inside there moves horizontally, and if that's a +1, it moves opposite. So it's going to move to the left one. The outside up and down moves the same way. So if I move a -4, it should go down 4. So I already can tell this is going to move down 1. Down 4 and to the left 1. That's going to be where our starting vertex is at. -1, -4. Right? There's our vertex. And with this being a +2 here, we're restricting this. We are going to be restricting this here to just the top part here, right? Oh, I'm sorry. With our cube roots, we don't have to restrict it here because we can have negatives with ours here. So this 2 is just going to end up stretching it. So all it does is just multiplies those every point that we have times 2. All right. And then this ends up being the graph that I told you of where that vertex is at -1, -4 right there. Again, as we can tell, we have a graph. So just make sure you know how to read those graphs there, how it stretches or shrinks, how it moves left or right, and how it moves up or down. Okay. That way you can be able to find a vertex point at least. Okay. All right. So your homework here. Homework will be due by Friday, April 3rd, 11:59, same time. virtual office hours from 1 to 2. Again, Thursday's the last time to come to virtual office hours. So if you have questions, come by. But a big thing for this lesson here is make sure you have your calculator. That's going to be a big thing for you guys. All right. Other than that, guys, it's pretty straightforward. Again, make sure you go back if you need to look at that reference part there for the table that we had. It's a really good reference for us. But other than that, guys, I'm here. If you need me, email me, remind me, whatever you have to do, just get in contact with me. All right, you guys stay safe.